Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the McKinney. This is their number MK80A. This is a concealed hinge is what this is. This is one of those relatively new. I mean, they're not new. They've been, three-way adjustable concealed hinges have been around for quite some time. McKinney's offering, I think, is relatively new in terms of these hinges. And, a lot of people like these hinges. This hinge platform has a lot of fans out in the world. I can't say that I'm among them, absolutely, and I'll explain why later, but I do believe I'm in the minority of that opinion when it comes to these hinges. They are super elegant in the sense that they're just concealed. You're not going to see any of this when the door is closed. They operate very in such a way where they will provide an incredibly clean, finished look to the overall opening and aesthetic of what you're dealing with. This is a little bit smaller of a size, and I don't know the weight rating for this, but we're going to get to that when it comes to hinges like this. So the entire premise of an MK80 type hinge, whether it be McKinney or anyone else who manufactures them, I'll tell you the McKinney is priced very well compared to its competition. I don't believe you'll hit a price point like this McKinney hinge. The reason people like them is because they're able to adjust the door in the opening in 3 dimensions. They can get a little lift, they can get a little lateral, and they can get a little lateral, then they can get a little side-to-side adjustment. And every time that I speak to people about these, usually the conversation is they're dreadfully fearful of using the classic hinge that is available in the market and has been for decades by Sauce. Everybody knows the Sauce name. There are people that are just dreadfully fearful of those because there's no concept of adjustability. Your mortising must be exactly spot on with no tolerance for deviation, period. That prospect to many people, and let's face it, if you had 100 people who installed these hinges, how many of them are doing it for the first time? 90? Okay? So to the overwhelming majority of people, the concept of an adjustable option is absolutely, as soon as they hear that, they're like, done. That's the one I want. And that's the prevailing attitude with this type of hinge. I approach from a different perspective where I have machined doors for every possible piece of hardware, whether it be with a hammer and chisel, or it be a router and a template, all the way up to having the shop program a CNC router. So I'm not personally fearful of mortising it in the correct location, but that is an absolute requirement for the traditional Sauce style hinge. An advantage of an adjustable hinge is, frames do move a little bit with construction. Doors do move a little bit. The classic Sauce hinge, there's no possibility of it loosening at all. In 30 years, I had only one client who said, oh, that hinge failed on me, and long story short, it turned out someone sat on top of the door and literally bent the hinge. Okay, but with this 3-way adjustable model, it substantially reduces the requirement of utter precision, and I think it substantially reduces the anxiety over that. It is a smart idea to be able to adjust something. I certainly don't deny that. My concern over this concept is you have mechanical fasteners holding the door in position. You are mechanically adjusting this hinge. What happens when the screws get loose? Okay, that's my concern. I have spoken to, just in particular, a client of mine who has been using this concept of hinge for a decade, and I expressed my concern, and they had told me, this gentleman in purchasing had told me he had never a single complaint of that. So I was greatly relieved when I had heard that. So the this video is going to be a visual tour of the 80A. You're going to get a hinge. They're sold as each. If you buy two, they're going to come in one box. If you buy three, there will be one loose or one in a box and two in a box. Doesn't matter. They're just sold as each. You are going to get the finish caps, and this is a satin chrome version. And the satin chrome version, these are just plastic caps, and they literally push into the preparation on the hinge. You can see these 4 small holes. Okay, and they're just going to dress that off. And clearly, those caps are available in different finishes. The knuckle assembly has to be ordered in the proper finish, but the caps are just swapped out. So you'll get those in the color that you request. There will be 4 needed per hinge. 2 of them have the corporate logo. Now, what's interesting is they have the UL symbol on there. And that means that they are permissible for use on a fire-rated door. That would be the reason for having the UL symbol on there, because there would not be... I'm not seeing a reference to fire rating in their paperwork, however. Yeah, they do not indicate that they're fire rated in the documentation. The fact that they have a UL symbol and a letter F right below it means that it would be not only fire rated, but approved for positive pressure testing. The capital letter F is how you know it's positive pressure rather than neutral pressure. A lowercase f is neutral pressure. I'm going to pause this video and ring McKinney right now and confirm whether or not this is permissible for use on a fire door, because obviously that's going to be a game changer if you can or cannot. So I'll be right back. Okay, so I paused the video, and right now I'm in chat with someone at McKinney waiting for a response on this. So you're going to get this hinge, and this is a part of a family of concealed hinges from McKinney. And when we get to the product catalog, we're going to go over that. That product catalog is going to show us three sizes: the 40, the 80, and the 100. And I know I've sold the 100 in the past. I don't believe we've done the 80. Pardon me, I don't believe we've done the 40, the much smaller version. And so the hinge, the decorative plates, and then, of course, your fasteners. You're going to get machine screws, and you're going to get wood screws. You'll need a total of 4 per hinge. And there are indeed a total of 4 of each machine screw and wood screw. So someone has connected here in our chat, and I'm posting the question. I see the UL and positive pressure F symbol on the decorative plastic cap. Is this hinge approved for use on a fire door? The reason I ask is I don't see the approval listed anywhere in the published documentation. Please advise. So I'm waiting for a customer service rep at McKinney to review. So we're going to get those components along with the installation instructions, and we're going to go over those in this video here. And the customer service rep is typing and is going to, they've stopped typing. So while I'm waiting for this answer to come back, what needs to be immediately understood about this premise of hinge is 2 things come to mind. When you have an overhead stop, okay, McKinney has sister companies that manufacture overhead stops. That overhead stop must be ordered. They've told me that they have to email me the answer. Okay. So the rep has told me that I need to email tech services, so if I get that answer during this video, we will obviously have that answer. So when you are dealing with an overhead stop, you need to order the overhead stops and specify the means of hanging the door. If it's hinges or 3/4 inch offset pivots, I wouldn't worry about it. Your template's going to work out of the box. If you're doing a concealed hinge like this, you need to go to your overhead stop people and say, I need this overhead stop for this application. I've got a door so wide, and this is the hinge it's hung on, because the templating is going to change. Or you can count on it. Don't count on it being the identical templating. I've had people install material with standard templates and then use concealed hinges, and they say, well, the door swings, but you can tell it doesn't swing fluidly. It seems to grind or slide or get hard as it opens, and yeah, that can be expected. The reason is because if you just kind of focus on the center of our hinge, if you just focus on this point where the intersection would be as I open and close the hinge, with a hinge or a pivot, center hung offset, the vertical axis of pivoting is a static plumb line. It doesn't move. With a hinge like this, that vertical axis of pivoting actually moves, okay? And that's the problem that you have with not calling it out. Now, the other problem is not calling it out. You won't get the template. Now, you can get the template. You want to make sure it's going to work, but they will cost more. And I don't believe there's any change in hardware, but the reason it costs more is they have to do paperwork, or they have to confirm, verify, research, things of that nature. So that's absolutely crucial when it comes to these hinges. The other thing that's absolutely crucial when it comes to these hinges is you can see when the door is closed and then you open the door to 180 degrees, this is a very fixed amount, okay? This is a situation where the back set of the hinge, as measured from the pull side, so not the hinge back set, but the dimension from the pull side of the door to where the prep starts, can only be up to a maximum dimension. Otherwise, you'll go to open the door, you'll open the door, and then all of a sudden the outside corner of the door is there will be a conflict with the frame. So observance to the template is mandatory for that dimension, that you do not exceed that permissible dimension. So those are the two major caveats with this material. Why is that latter an issue? Well, if you have some chair rail on a wall, if you have some sort of applied molding, if you have a deep inset, this hinge is not going to work. McKinney's line of three-dimensional adjustable hinges is garden variety material. They do not have a broad offering of what are ultimately very unusual hinges to account for applied material. You might be doing a 3/4 cladding on a door. Well, that hinge has to be a very different animal, where to account for the fact that your frame will be here, your door is going to be inset, and then you're going to have 3/4 inch cladding. So that's a different hinge at that point. So those are the two major caveats with this material. So I think the thing to do at this point is to switch to the screen view, where we can talk about this hinge and its supporting documentation. Before we do that, I just want to tell you what other colors they will do this hinge in. Okay, well, you've got lots of choices as long as it's between two. Satin chrome and matte black. That's good for matte black. Matte black is the new oil rub bronze finish in the world of hardware in 2018, 2019, 2020. Black is very, very common and popular right now. So those are the two finishes. And in fact, in their 40A, their 80, their 80A, and their 100, those are the only two finishes available. Okay, let's switch to the screen view, where we can take a look at our supporting documentation. Okay, so this is the item that we're looking at, and by the way, I did get a response from our tech support contact at the manufacturer, and they told me that the MK80 and the MK100, those are indeed rated for 20-minute applications. Okay, so we have an MK in this series. We've got three hinges. The MK40 is not rated at all. The MK80 and the MK100 series are 20-minute rated. You'll see that there's an MK80 and an MK80A. The MK80 does not include our finish covers. Okay, so that's going to have a different look to it altogether. Probably, and we'll explore it, but probably very little price difference between the two. So fire rating on the 80 and the 100 series. So here is our item, obviously shown here in the black finish. That, of course, is a important area in which to start, whether or not your door is fire rated. If you have something that's beyond 20 minute, you have to, of course, have hardware that is listed for that type of application. This McKinney hinge is definitely labeled on the back side of one of the two leaves, which would be required for a hinge like this to actually physically bear a label. And while I saw the label on the material and of course on the faceplate, it was of concern that it wasn't in the published documentation, which is why we reached out to double check. And plus it doesn't indicate a rating that's on here, so eliminating the guesswork and the lack of clarity about what it's rated for, now we know. So we're focusing on the MK80. Let's switch back to our item as seen here and work our way down. Concealed hinge, satin chrome. This is obviously the black finish. And refined, minimal McKinney concealed hinges feature 3D dimension adjustability for easy installation and door alteration. The snap-on covers conceal the screws for a clean aesthetic look, and that's what the MK80 does not do. Concealed hinge, covers included, zinc alloy is the base material. Satin chrome would be a reference to the covers and the knuckle of the hinge finish. The size of the hinge, we're going to go over that when we take a look at the template. This will go to 180 degrees, your door will. You can go with a plus or minus 2 millimeter height and side to side with a lateral depth dimension of plus or minus 1 millimeter. So 1 millimeter, to put that into perspective, 1 divided by 25.4 times 1, so it's 30 thousandths of an inch that you can move it. And obviously with a 2 millimeter it would be 78 thousandths, or just heavy on a 16th of an inch. And you know, that's certainly nothing to shake a stick at. I would say it's if you want an adjustable hinge, that is going to give you some adjustability. There's no doubt. It's more than a 16th, and it's about a 32nd in the other direction. For wood or hollow metal doors, for wood or hollow metal frames as well, your custom manufacturers of your hollow metal frames can certainly manufacture for these. They don't do it often or all the time, in my opinion, but they certainly do come across it. I have had my custom hollow metal manufacturer make doors for 3-way adjustable hinges in the past, and it's worked out without any trouble. This is another caveat, a minimum door thickness, which is, you know, the case for all means of hanging a door, whether it be a pivot or a hinge or a concealed hinge. They all have a minimum thickness, and this does, of course, too. Sold as each. When you buy one, we're going to ship you one. If you need 3, great, you can order 3, not a problem. And this is where the where it starts here, with how many hinges to use. And what's nice about these is that they will handle a very modest, they will handle a very generous weight range. So just 2 hinges are rated for what would be considered a quite heavy 3-foot door. So you're going to be able to easily handle 3-foot doors that are going to be, you know, incredibly heavy. You might even be able to do a simple 30-second lead line door. I'd have to look up what that weight is per foot, but you could probably hang a lead line door with it as well. You can see, though, however, as the width increases, your weight capacity decreases, and that's pretty standard. That's evidenced by how we can see in best practices as they are outlined in our industry. When your door gets wider than 3 foot, and most certainly 3 foot 6, 42 inch and wider, you're going to be at a taller hinge so that they can compensate for the wider door leaf. So you'll go from a 4.5 inch leaf to a 5 inch leaf in these areas. Okay. So this is a very important document. Let's go back to the product brochure and make sure we haven't missed anything on that. Well, actually, from the beginning, this is a relatively new sort of publication from McKinney, and they've gone in an interesting direction with gravitating towards the ability to cater to the market when it comes to more unique solutions, perhaps more elegant looking solutions. A flat tip is in essence a button tip on your hinge, but that's clearly more decorative. These sorts of tips that they have here on their 2, 3, 5 knuckle hinges, those are going to be particular to McKinney. They have some nice looking options here. That radius tip. Also, McKinney has their square knuckle hinge as well. And here it is. It's a 2 knuckle. They're handed. It's a 2 knuckle square barrel hinge, which is really cool in the sense that it's going to look like your hinge leaf. Forgive the awful artistic rendering, but that hinge knuckle is going to literally look like this. It'd be square, but it's going to look square so that when you're looking at it in elevation, you're literally seeing a square profile. Okay, those must absolutely be ordered as square or beveled, because if you imagine in your mind's eye, how that door leaf is going to sit on the door, whether it's square or beveled, it's going to affect how those square knuckles in the 2 knuckle hinge line up. A 3 knuckle version as well. Really nice looking stuff. Then of course they're concealed material, non-handed, so they can go left hand, right hand, doesn't matter. Flip them around. 3D adjustability. Your weight capacities are here, your minimum door thickness. Now, if you're doing full-size doors, the MK100 is really, I think, going to be more typical in a commercial setting, most certainly. I would say that if you're doing residential material, that the lighter duty material would certainly be possibly more appropriate, or even the 40 series, because interior doors in a home are not going to be fire rated, with the exception of possibly that garage door, the attached garage door to the house. That might need to be 20-minute rated or more. Depends on your local code. But let this information drive what direction you head in. I don't see any trouble with weight rating on the MK80 if you're really residing in the 3-foot area. You get out here, you're really not going to see 4-foot doors that are going to be comfortably 158 pounds. 4070, 4080. I really think you're going to be at the 100 series for commercial. That would be my option. I would prefer to have more hinge rather than less hinge when it comes to the lifespan of the opening. Olive knuckle hinges are neat. They're alive and well. I remember the first time I mortised a door for one of these back a long time ago. I stared at that template for probably a half an hour before I put my route around the door, just to make sure I was really, because the problem is it wasn't referencing a center line on the template, and I needed to breach the face of the door, for my leaf, and that baked my noodle for a little bit. But getting through that, learning how to read templates, is really the key to success, which of course does dovetail us into being able to machine for this material. So let's move now to the installation instructions. Now we're moving on to the installation instructions. Let's get the cut sheet first. There's probably not much there. It's a redo of the product catalog, basically. Okay, be nice if you're going to, of course, need to. Actually, it's got a lot to do with the installation instructions as well. Shows you the dimensional properties that you're going to be contending with. 25.4 is going to be the important number moving forward. And I'll explain that in a moment. But if you're going to include this paperwork in a submittal package, here would be your document. Now, let's tackle the installation instructions head on. So I've prepped for these, I've mortised for these. You know, it's easy stuff. You just have to do what the template says. In terms of mortising this material, it is, you know, there's not a tremendous challenge to it, you know, really at all. You know, what I find is you're going to make yourself a template, is what you're going to do. I'm not aware of McKinney having a template for these at all. Let's face it, you know, door companies that are going to be prepping, or I should say door manufacturers that are going to be prepping for this material are going to use a CNC machine. There's no doubt about it. However, let's just imagine you don't have one of those in your back pocket. You're going to be doing it. You're going to be doing it by hand. So you'll make your own template would be my recommendation. And, you know, the way that I would go about doing it is I would, you know, drill myself a hole to achieve the 14.5-inch radius. I would just literally take a piece of 1x poplar, and I would cut it to the size that I wanted. I would just quite simply prepare it in such a way that I had 5.5 millimeters from the pull face of the door and the side of the and the face of the frame, and that's where you've got to have an understanding of what is your inset. So you'll have to account for an inset. You might determine your inset, and that you're going to have to adjust accordingly, because what I mean inset is the face of the door. Let's just say that this is your frame, single rabbet frame, whatever the case might be. Your door is going to sit in here. Here's an exaggerated bevel. The inset is the dimension from the face of the frame to the face of the door, and what they're saying is your prep cannot exceed from here to here that 5.5 millimeter dimension. So you have to add to that, obviously, what your inset is going to be when you're going to translate that template to the jamb itself, so that you've got 5.5 millimeter plus whatever your inset is, so that you can get your prep in the center line there. So I would take a piece of 1x material. I would, you know, give myself a 14.5 millimeter radius prep here and here. You know, they're saying that it's a 37/64 radius for the body, a little bit wider. Or maybe it's not wider. Yeah, a little bit. I would say it's a little bit easier. Well, we can just translate it. Let's figure it out right now. So 1 divided by 25.4 times 14.5.57, and the other one was 60. Oh, okay, they're the same radius. So here they are at 37/64. Okay, so that's the only dimension they have tossed in here. That's an empirical that I see. Forgive me. I was thinking I wasn't paying attention close enough. So you've got a 14.5 millimeter radius. You know, obviously that's 0.57. So 0.5625 is 9/16. That ought to work for you. I did not grow up when metric was taught in the school system. I don't know if you can get a 29 millimeter hole saw. If you can, that's what I would buy to make myself this one-time template. And then at that point, what I would do is I would mark my 4 holes, and the way that you have to choose how you're going to do this. So you can come up with a block so that you are not routing into this area when you do the deeper body prep. So this line goes straight across, right? This line goes straight across. So this body prep here is what we're looking at here. So you're going to need, or you might just use, two templates perhaps, or you could also come up with a insert that you would place inside of here to limit your router from going any further. The issue with that is you're not going to have this type of graceful mortise unless you got super fancy. If they exist, a 29 millimeter diameter 2-flute, carbide bit, you might be able to toss that into your plunge router. That's interesting. 29 millimeter router bit. Yeah, I'm definitely not seeing that come up instantaneously here. So I'm definitely not seeing that. Going to need to come up with how you're going to go about doing that. You might use two templates. I know there's another manufacturer that has an inserted pin. The issue with that is, so as you move forward, the way that you will ultimately end up doing this is how you're going to achieve that, is how you'll achieve it. I would just be using a template that I would be able to apply to the edge of my door. Obviously, a template's going to have a couple of inserts where you'll be able to physically nail the template down to the edge of the door. How you'll end up going about fixing it down to the door. Yeah, nails are generally what's used to do that. You might try to not pierce the edge of your door. Depending on the construction, you might find a different way to do it, maybe clamping it to the door. So you're going to need to, and I like to use a plunge router, just a 2-flute 1/2-inch diameter plunge router. Now, if you were to have a hole drilled in the edge of your template and you inserted a roll pin into it that you could, or a nut and a bolt or whatever you would insert through there, if this area here and here and here and here was not radius like this, it's not going to be the end of the world. Because it doesn't matter. Just so long as, if you were to basically cut this straight across, it's really not going to change anything on the hinge prep whatsoever. So I wouldn't hesitate in doing that if it served getting it done better. And, if you were to do that, you might insert a couple of rods, not worry too much about the prep on the inside corner, and have a nice easy prep. Then the only thing you have to know at that point is how thick is the faceplate and how deep to make the pocket on the door and jamb. And you can very easily use your stop on your plunge router to get you your depth. 22.3 millimeters, 36.3 millimeters. Then your plate thickness is 6 millimeters plus, I guess, a third, or 0.3 millimeter, I guess is what that means. So super easy to do that as long as you observe this. So I just spent the last 5 minutes talking about how to make a wooden template, when the moral of the story is observe this, add your inset to observe this. You have your height at 111 millimeter. You have for your plate, this is your plate. This is your body prep. Your body prep is going to be 69.5. Your depth will be 36.3 for the body and 6 millimeter for the face, then 22.3 for the body on the jamb, and that's it. Then all you have to do is make sure that you get the center line the same for both. So if you're doing a door and frame and you have you've got a door, that's awful. You've got your frame. Okay, the question becomes what's the margin in here? Is it 1/8 of an inch? Great. So what you measure underneath on the underside of your head to the center of your prep, when you translate that dimension to the door, deduct it by 1/8. And then you're going to be perfectly in alignment. There's no way to get it wrong. And in fact, when you mortise it that way, you're not going to need any of the adjustments. And in fact, I think the adjustments will become a bit of a hassle because you have to adjust it. So at the end of the day, that's what we're dealing with. So that's the hard part of the entire installation process that we just blew through. Let's start over with the easier stuff. You're seeing right here the factory's recommended placement for 2 hinges, 3 or 4 hinges. Now what you're going to notice is the location for 3 hinges. They want you to soldier stack those. Well, not soldier stack, but you know what I mean. Bias the middle hinge towards the top of the door by coming a third of the way down. The issue with that is that's not going to meet the criteria for industry published standards for location of hinges. So I would be cautious. If you're doing wood doors, I would contact the wood door manufacturer before selecting these hinges and get in writing that any warp in the door will not be attributed to a location of hinges as laid out here, okay? Because industry standard is for doors up to 60 inch, you use 2 hinges. For every 30 inches after that, you add another hinge. Well, the problem is we're going to have more than 30 inch in this space. I mean, you're going to have more than the margin of adding another hinge. So I would want to get that clarified before I move forward. But you'll see these 2 hinges at the top as standard practice for places in Europe, or if you've been on a cruise boat, you see it as well. And the reason you see it on cruise boats is because many cruise boats are built in Europe. That's where they put the hinges. Your load capacity is mentioned here that we talked about earlier. It's important to note they say the hinge spacing does not affect load capacity. The first door should always be checked prior to preparing any more doors. So where you locate the hinges are not going to affect your load capacity. And that's because, you're biasing that third hinge towards the top. 70% of the weight of the door is borne by that top hinge. So, if you're going to have 2 hinges or 3 or 4 and you're observing this chart, no, because the placement of the hinges is directly related to the load capacity. So if you were to change the locations here, then all of a sudden this statement is not necessarily accurate. Minimum door thickness 1 3/8, minimum door height 80 inch. I don't see why you couldn't put it on a door that was 6 foot tall. I don't see a problem with that. But what they're saying is prep your first door, double check everything, make any adjustments, then proceed. Okay, so we've covered the first page. They give you those overall dimensions, but everything you need is here. Now I had said 25.4 is a important number. The reason it is because, as I said earlier, I didn't grow up being taught metric, but there's no reason to have a problem with it because of 25.4. If you're in the door business, you understand, decimals. Well, metric is nothing but decimals. So 1 divided by 25.4 multiplied by, whatever number you need. So if you wanted to find out, what 14.5, millimeters is, 1 divided by 25.4 times 14.5 was that 0.57 number we had earlier. So again, just 1 divided by 25.4 times 14.5. Okay, it's 0.57. And in my head, I know what 9/16 is. It's 0.5625. So I'm just going to be heavy on that, and like a 30-second heavy on it. So the point is when you're looking at that template, if you need to break it down into these numbers and then look at your fractional chart, and knowing what fractions break into to decimal points, that's how I do it. I don't have millimeters memorized. I have no reason to memorize them because I can break that math down. Here's a great little cross section showing again what we're contending with, but this is just a regurgitation of what we've gone over. But they're giving you the information laid out in such a way that you can relate it to different door thicknesses. Now, and I have a comment about this. They have door thicknesses, 1 3/8, 1 3/4, 2, and 2 1/4. They have a C1 dimension, which we know is that crucial 5.5 millimeter. And they're also giving you a C2 measurement. That's nice, but I wouldn't touch that C2 measurement. And the reason I wouldn't worry about that, as long as this is absolute, your C1 dimension, the reason that I wouldn't worry about C2 is because an 1 3/4 inch thick door, 1 3/4 inch, does not equal 1.75. If you put your caliper on any door, I guarantee you that 99% of the time it's not 1.75. Fire doors are going to be 1.71, 1.72. 1 3/8 doors, 1.31. 14 gauge steel stiffened doors, 16 gauge steel stiffened doors, 1 3/4 inch, yeah, they're 1 7/8. So my point is, this, I would take C2 as a reference, but not an absolute, whereas not exceeding 5.5 is an absolute. Otherwise, you know what, let's switch to the screen view where I can demonstrate that, why it's an absolute. So the reason that 5.5 is an absolute is because this is the door, and the door is going to swing out this way. If I put my fingers, and I imagine that this was the 5.5 millimeter, okay, and just watch what happens. I don't really get into any trouble with any conflict with the frame, just the tip of my index finger. I don't get into any trouble. But if I were to increase that by, let's just say my tape measure, this is the new 5.5. Now you can see, oh my gosh, I'm literally going, I'm now hitting the frame, okay? I'm hitting the frame. So if my dimension of the face of the door to where my prep starts is greater than 5.5, I'm going to have trouble right there. I'm going to hit. And I'll never get my door even remotely close to 180 degree. Okay? Now you can see why that's a gross exaggeration, but it serves to prove the point as to why 5.5 is such an absolute. Back to the camera screen view. So then they show you in cross-section what your dimensions should be. They do not give you a dimension from the face of the stop to the face of the door. Industry standard on that, I would not go below 3/32 of an inch. If you find that you have a little bit of trouble, you might have to chamfer that edge over, just slightly. Very, very slight chamfer on that. You're going to want to make these beveled. You know, it would be my opinion. This can tolerate a bevel door, obviously, because all that's going to do is make the hinge just sit out this way ever so slightly. The L dimension is... Okay, so they're saying the minimum gap will be 2 millimeter, you know, between the door and frame. What is 2 millimeter? I know that we like 1/8 of an inch or 3/32, but 1 divided by 25.4 times 2 is 0.07. So that's like just heavy on a 1/16 of an inch. So yeah, that's really, really small. I would be making my gap typical. I wouldn't go below 3/32, which is about 96 thousandths. And maybe, and as much as 1/8 of an inch. 1/8 of an inch is very standard. You know, 3/32 if you're beveling the door. 1/8 of an inch if it's a square edge door. And that covers everything that's here. Okay. Over here, they're going to get into how to adjust the hinge, and that takes a little bit of study. Installation, let's just cover this part. Insert each hinge section marked door into door socket. So literally on the hinge, not on the label. The label that's attached, the adhesive label will say door hinge. That is not the door hinge portion. The door hinge leaf, so to speak, is the thicker, the deeper, the larger portion. Okay, they are clearly different depth. The door is going to be the bigger half. What they're saying is get your hinges on the door, attach them. Then set the door on the frame by inserting each loose hinge section into the socket created in milling. I feel like someone who wrote this, you know, the American approach to mortising doors is not is not their background. Socket and milling, we wouldn't call it milling, mortising. Secure each hinge with your screws. Make your adjustments. That's when we get over here. And then after you are done making your adjustments, you're going to push your covers to hide the screws. If you're going to pull them off, be very careful because you can easily snap the little plastic prongs. Now, let's talk about the adjustment, then let's demonstrate it on camera. Okay, now in the interest of moving us towards the end of the video, let's just go over the adjustment by reading it. It's not obvious and straightforward what's happening here, in my opinion. The key is what needs to be done is an understanding that you have to move one screw a little, then move the other screw a little, then go back to the other one, and then the other one. You have to do it in steps because you have to make that adjustment on half of the hinge to then mate that same adjustment on the other half. So adjustments to hinge are made with a 4mm Allen wrench. I have, unfortunately, an Allen wrench is not included with this set. I wish that they were. Yeah, it needs to be 4mm. Well, I mean, it can be the imperial size, but there is a very close imperial size. I forget what it is. Well, obviously, what would we do? 1 divided by 25.4 times 4. Okay, so that's going to be like 5/32 of an inch, I think. 1 divided by 32 times 5. Yeah, so, okay, 1/1000th of an inch off. So 5/32 may work, but it doesn't fit as nicely. Just be mindful of that. 4mm Allen wrench. All hinges should carry the load for proper installation. I'm not sure what they mean by that. It just install them correctly. Your vertical is going to be literally these. You'll notice this is radiused. You'll notice this is square. That's going to be your vertical adjustment. Vertical adjustment, make sure the top adjusting screw is even with front surface of hinge. If it is not, unscrew it to that position. You're going to want to make it flush is what you need to do. And what they're really saying is that the screw itself can be below the surface or above the surface of the leaf, and I'll show that to you in a moment. So the vertical adjustment is plus or minus 2mm. Make sure that that screw is flush. I'll show that to you in a minute. If it's not, put it flush. Adjust hinge by turning bottom adjustment screw. After you've got it adjusted, tighten the top adjustment screw. So you need to put the top screw in its neutral position so that you can then drive the height accordingly, clockwise or counterclockwise, and you'll fix it with the top screw. Your depth adjustment, your B and your C, are handled at the same time. That's goofy to say that they are. They're not handled at the same time. The hinge has a range, let's say from far left to center to right to far right, so to speak. The more you turn these screws, the more you will adjust the lateral position, then the depth, and then the depth, and then the lateral position in the opposite fashion. Depth adjustment and horizontal adjustment take place simultaneously. Adjust hinge by alternately turning both screws. Once you have that done, put your covers where they belong. Let's wrap up this video on camera with a demonstration of the adjustment. So let's tackle the easy one first, I suppose. You've got your hinge adjustment. Those are loose. Okay, you can see where that adjustment's going to come into play. And as I take my 4mm screw, that needs to be flush. So I can take my Allen wrench and I can turn that out so it's not flush, and I can turn it in so it's not flush. You've got to make it flush. Then at that point, you're going to hit the lower screw, and you can see how I'm adjusting the height. I've turned it all the way up. Now just watch the margin right here as I turn it counterclockwise. Okay, I'm dropping that down. Once I got it where I want it, tighten the other screw. Easy. You have to do it in that arrangement. Now, the side to side and the depth and the side to side, kind of adjustment. Right now I have that thrown out at its maximum. You can see that huge gap that's there. So as I rotate the top screw, if you just focus on this plate here, I can turn that maybe a half a turn before it's going to kind of stop. And you can see how much I change it. So I'm really changing. Let's do this. I'm really changing that depth position. Okay? I'm really not affecting my... I am a little, but I'm really not affecting my side to side. I'm affecting how the door sits in relationship to the frame rabbit in its pocket. But it'll stop as I turn it about a half a turn. That's because I got to get down here and turn this one a half a turn as well. Okay? Then I can go back to this one. I'm sorry. I can go back to this one and affect more change to it. Then I have to go down here and affect change to that. And when it gets firm, you go to the other screw. And you continue to work it this way until you get a depth position that you want and a lateral position that you want. So I've taken these two adjusting screws and I've moved them in the opposite orientation. I've turned them all the way to their opposite. Now that hinge is far deeper in the pocket. So what's happening is the hinge moves this way, then this way. The hinge moves this way, then this way, and this way. That sort of concept. And that's how you have to approach the adjustment. Okay. Other manufacturers, I have to tell you, other manufacturers approach it differently in the sense that there are more things to stick an Allen wrench into. This is pretty smart though, because you can literally affect how the door sits in its pocket, okay, and its side to side by using the same screws. You just have to do them, together, well, one alternately, and then you have to go to the next hinge. So it's a bit of a tedious task. Now, my concern is, what's the integrity? What's the long term? Are these plates going to move? Are these screws going to turn with time? Is there a maintenance concern? Should I be worried about the health of this hinge in 10 years? You can see how much closer those are now that I brought them in. And like I said initially, I spoke to a lifelong purchasing agent who has come out of manufacturing and in the woodworking industry, and he has told me at least 10 years he's not had a single complaint. Not on the McKinney hinge, but on the concept. So I've got to take that as firsthand knowledge. There's no doubt about that. I think at this point it's time to wrap up the video. Nice quality company McKinney is. They are part of Assa Abloy. Assa Abloy is a name synonym, is a multinational, multi-billion-dollar corporation. Assa and Abloy. Assa and Abloy are known for high-security cylinders. An Assa cylinder is a high-security cylinder that has normal pin tumblers, but then it has a sidebar design. The Abloy, their ProTech, is a highly unusual high-security cylinder, super cool, that has a number of discs in it. And as you turn the key, the way and the shape of the cut on the key itself will affect its relationship with that disc, and how the cut is on the key governs the rotation of that disc. And when all the discs are lined up, a locking bar, which is the fence, can fall into the gate, permitting the cylinder to turn. Really cool. Well, over the decades and decades, Assa Abloy and all these other companies that they own, they have, many years ago, in fact, a few decades, they, purchased, many American properties like Medico, who owns 75% of the North American high security cylinder market. Rockwood, Sargent, Corbin Russwin, Yale, McKinney, Hess, Adams Wright, Pemco, and the affiliates that they have, the sister companies that they have that are outside of the United States. I couldn't even tell you. I mean, it's epic, to say the least. So they're under that umbrella, and the advantage of that umbrella in this instance is that you saw that McKinney catalog, and it seems to me that they really put a effort into saying, hey, we've got all this really cool hardware. There had been a publication from Assa Abloy that was Sargent and Rockwood and McKinney that basically said, hey, listen, if you can sketch it, we'll quote it. Handles, finishes, designs of hardware, and that can-do attitude really comes through. And I know it very firsthand with Rockwood. They have, who is a sister company to McKinney, they have a great can-do attitude. Finishes, custom designs, etc. So the point of all of that is you have this huge surrounding environment of can-do, with McKinney being associated with so many other companies, in my opinion, winning companies. Why would you use someone else? You know, maybe the McKinney Hinge is inferior. Maybe it's superior. I don't know. I'm not an expert in terms of the long-term reliability of three-dimensional adjustable hinges, and I'm a fan of just the good old-fashioned ones. And the McKinney Hinge will not do all of the applications, because if you dive into the world of concealed adjustable hinges, there aren't just one type in three sizes like McKinney has. There's a lot, and a lot of metric. So if your application calls for something outside of what McKinney can do, then look elsewhere. But, you know, we've just demonstrated the Hinge. Everything seems to be simple and straightforward. And at this point, I would not hesitate to suggest that you review it. Any questions on the McKinney? This is their part number MK80A, concealed hinge, or any other McKinney product. Please feel free to reach out to us. And thank you.